And yes, I think it's important to note too that these are going to be things that were brought up that were maybe like errors or common themes of like points that we wanted to bring up again to make sure they weren't made again. Not saying that if this was brought up, just that one person made that mistake, but they're only in this presentation if we saw it come up multiple times. And that we're not going to be mentioning things that were done really well either, because we did already mention that in the report. But I often find that I like hearing things or like areas of improvements when I receive work back, just so I know that I don't make it again in the future. So first, we're going to talk about mapping. And so a couple things were the GIR feature classification. And so one of them would be the triangular facets. And this one can be still a bit tricky depending on the faulting environment, because oftentimes like at the base of a range front, no matter what, if it's the base and it goes into a flat line land, it can give the appearance of a triangular facet, and they can exist outside the context of like a tectonic setting. So like in this instance, this is in Parkfield, California. You could see that the hill slope or the mountainous region goes into the flatline land, and it can give the appearance that it's a triangular facet based off of where the drainages are going out, and it might give the indication of faulting. But we do want to be a little bit careful to not mark everything at the base as a triangular facet and a result of faulting, because this one you can kind of see, and I'll annotate it, that right here, this might look like a triangular facet, that might look like a triangular facet, and this is just based off of the SRTM. But if we were to look at then the base imagery, and not every project lets you have the base imagery, but if you do, you can toggle on to the next one, and you see that it's just going into urbanization or a flatline land or active water. And it's not necessarily stopping because of a fault dropping the range front, but it's just actually going into some kind of anthropogenic alteration. So just double check, I guess, if the triangular facet is there actually because a result of faulting, if there could be other geomorphic processes that result in the appearance of one. And then the next one is a beheaded drainage. And so this one is back from the example of Wallace Creek, because it's very apparent here.
You want to see if people have any questions on the facets?
Yeah, if anyone has any questions too.
This is Rich. I have one thing to add about triangular facets. It's usually to consider them in association with other features. So a triangular facet by itself, without any other features, may be related to something else. But if you see triangular facets along strike, or associated with a scarp or some other feature like a wine glass canyon or something like that, the more features that you can see along with the triangular facets gives you a little bit more confidence that the facet is related to faulting as opposed to something else.
Yeah, and it is a feature.
Question here in class about what are some of the other causes of triangular facets, and well, it could just be erosion and incision by a river system along the margin of a mountain range or something like that. Anytime that you're cutting into the range and erosion is happening upslope, you can get features that are similar to triangular facets, but are not. The other thing is to look at the mountain scale. So if you see facets that go all the way up to the crest of the mountain, if they're tectonic, there should be other fractal scales of facets that get smaller and smaller going down towards the range front. Because recall that the initial offset creates a displacement along the range front, and then the streams erode through it. So you may have small facets that may not be completely triangular at the base of the range, but then they get kind of more and more bigger as you go up the range. So association of these different things, the fractals, other tectonic features, just help you assess that it's tectonic noise.
Yes, yeah. And I think, and it's a feature too with the ranking of 3, which means it requires kind of like that higher level of evidence, like Rich has mentioned, in order to like properly ascertain if it is a triangular facet or not. And then the next one, yeah, the beheaded drainages. So, and like when I took this class last year, I had a problem with labeling beheaded drainages too until it was explained to me. So in order for beheaded drainage to actually occur, and it's also very important about where you place the GIR feature when you're mapping the beheaded drainage, it has to be mapped on the downslope portion of the drainage that's beheaded by the fault. So anything that's on, like, let's say this is where the fault is, none of the beheaded drainages would occur on this side of the fault. It would have to be mapped on the downslope. And there also has to be evidence that the drainage is actually beheaded and not stopped. So there has to be some sort of evidence that the active water channel is no longer flowing through across the fault because of the fault cutting it across. And so you can see right here, there are many drainages on this fault trace, but not all of them are beheaded. So in between the two, right, can you guys see my mouse too?
Yeah.
Okay, so in between this one and this one's not necessarily beheaded because you don't see any evidence that there is active water flow on the other side that's now getting cut off from the fault trace. And so I think I had an area last year where I just saw a front like this, and I just saw a bunch of drainages and there wasn't necessarily any evidence, and I kept placing all of the beheaded drainages on the more deeply incised active part of the drainage, which isn't correct. It would have to be on the downslope part that's getting cut by the fault. And so oftentimes you might think that the fault is still beheading it, but if you don't see any active evidence, there might be another feature that would be more accurate to try and describe what's going on, or maybe a modifier like a morphologic element, a break in slope or something that would more accurately describe it. Does anyone have any questions about that one?
Can you describe why that's a deflected stream and not an offset stream, Rachel?
Yes, yeah. So it has to do a lot with like the angle too, with what how much the stream is being deflected or offset. So for offset drainage to truly be offset, it has to be similar to 90 degrees of offset. And then it also has to still be somewhat active or the fault is cutting across, but anything less than that is deflected. And another thing that helps me distinguish between offset and deflected, deflected is a low ranking feature, it's only 2, whereas the offset drainage is 4. And so the same thing with the triangular facets that Rich mentioned, that there should be features around it of higher ranking. If you see just what you think would be an offset drainage, but there's no real indication of other high outfaulting activity around it, then it's likely not an offset drainage, and it could be more accurately described by deflected stream. Well, any questions on the UNR side, Rich?
I think we're okay to move ahead.
Okay. And then this next one, the cut or offset alluvial fan. This is gonna be an example from the Landers assignment that we did, but it's gonna come up probably in the EMC for the repeatability mapping as well. And so oftentimes in the preserved arid desert climate environments, you will see the preservation of the faulting features within the alluvial fan, but the feature name of like what you're actually seeing in the landscape might differ. And so a cut or offset alluvial fan, in order to do that one, if you're using the AF or the AFC GIR feature, it has to show some kind of disruption to the natural progression of the fan, or you can kind of look within the drainages within the fan to see if those are offset or the surface units, because you can see some kind of maybe lineation in the surface, and that might be more accurately described as a scarp if you don't see any like real halt of the fan progression, if it's somewhere within the middle of the fan, or if you don't see any surface offset or drainages being like maybe deflected or changed by the faulting. But if you see some kind of disruption, you might want to use the profile tool across it and to try and see if you can maybe suss out a scarp or a different feature. Because again, this is going to be a feature that maybe like a higher ranking. So it's going to be a little bit harder to determine whether or not the actual like progression is being halted. And so if we look at the features here, like this one and this one, you know that these are getting offset or changed somehow by the faulting trace. But some of these other ones up here, it doesn't look like the progression is being halted by the faulting. And then if you went to go then put the fault trace, you can see that right here it's getting cut across cleanly. But up here, I didn't see any like true progression or cutting of the fan, so I didn't use that feature to describe that. And then if we look at a different example too of the alluvial fans, this is from the, I'm going to butcher the name, the Hanapa fan in Death Valley. And you could see here where there is like a very abrupt change in the progression of the fan. And if you zoom in into some of the areas and you took a profile tool across it, you can also suss out a scarp where the fault has cut across it and then changed it drastically. And it would be a little bit harder in this area too, but if you were to look at maybe some of the drainages, you could see those that are still active and flowing, that they are offset a little bit too. So if we drew the fault trace across this one, and probably cut across somewhere like right here.
Question about the alluvial fans. So to use the SSAF or the alluvial fan offset GIR, do you want it to, it sounds like you want it to be like cutting rather than kind of like shifting it? Is that the right, I don't know if that's the right terminology for that, but is that, do you understand what I'm saying?
No, yeah, I think so. Yeah, shifting is okay. So if you have, but it has to be like the entire fan is kind of a significant portion is being shifted, because if you just do like a little shift, that whole fan isn't being cut or offset by the, but the drainage might be deflected, or you might be able to suss out a scarp from it. And then I'll show an example of a different area in EMC that might like make more sense for the problems that arose from that area.
Cool, thanks.
Mm-hmm. Yeah, and so this is from EMC. This is in a different part of the mapping area than you guys are doing, but it's still kind of the same environment. And this is going to be a little bit uphill where those big fans are forming. And so when you see these little tiny drainages coming out, there were some alluvial fans mapped up here, but it's more accurate that the range front and the bedrock is just meeting the unconsolidated sediment, and it's not necessarily forming a well-developed fan where you would see evidence of offset from the fan progression, if that makes sense. The more developed fans are going to be further down, and you may see evidence of offset there, but up here they're not necessarily well-developed alluvial fans. But there could be some evidence of faulting that other GIR features could capture.
So here you would not map the fan in the GIR at least.
Mm-hmm. If you went down a bit where the larger developed fans are, you could see some evidence that you'd be able to use that GIR feature, but at least not up here.
Are you annotating?
Rich,
Go ahead, Rich.
yeah, I just wanted to say that sometimes a little further up on the slope, you don't really see the fans because they're coming down these narrow drainages and they're depositing out a little lower down on the slope. So sometimes you have like a quaternary bedrock contact where it's just basically like colluvium or something like that against bedrock. It can be sharp, and other features that can help you, determine that it might be a fault is maybe a change in the steepness at that contact, maybe over steepened along the base of the bedrock or something like that. So again, profile tools can really help. You can look at that slope and see what it looks like. If it steepens up a little bit right at the kind of colluvium bedrock contact, you have a little bit more confidence that it may be a fault.
Mm-hmm. Okay. And then done with the GIR feature classification, but So if anyone has any questions about the GIR features too, please let me know. We can talk about it more. And this wasn't necessarily an error that anyone made specifically, but it is a general challenge in fault mapping that we generally, and people in the industry and people with fault mapping experience will try to use fault range fronts to help identify the location of a fault. And oftentimes, if the range front is along the same strike, it could be a good tool to try and identify it. But oftentimes, not oftentimes, but there are cases where if you don't want to follow it too strictly, especially when the range front isn't on a continuous trace, because you can be neglecting other evidence that may indicate that the fault trace goes either upslope or downhill of the front. And so this is a case where, and this is on the right side, this is actually where the fault ruptured. And so you could see that it does follow the range front, but then as the range front kind of veers off and doesn't continue along strike, the rupture goes uphill a bit. So we just have to take a little extra care, especially when you're mapping in areas where there's like a front or open over-steepened contact that we're not strictly following it the whole way. Sometimes that is the case, like in the assignment that you guys did in the Washoe City, where the range front and the fault strike were quite similar, but there are going to be cases where it will deviate quite a bit.
So what's the take-home lesson from this example, Rachel?
Yeah, so range fronts, great to look at if you can find some GR features, but unless the range front is continuous along strike, or even if it is, don't strictly adhere to the strike of the range front to place your fault. So you still want to look up and down and around for other evidence of faulting, because the fault may completely veer off of the range front like it did in this case.
Yeah, and also, Ramon's comment, scour the entire assigned area. Look beyond the area, because remember that faults have steps along range fronts. You know, there's segments and different sections of the fault, and so it may not go along the range front the entire way. And so where there is segments, sometimes one of those segments can rupture by itself, but sometimes two of them can rupture together in a larger earthquake. And when that happens, the rupture is going to try to make its way over to that other segment, but it may not follow along the range front because there's some, geometric complexities and stuff. So it's going to find its sort of easiest way to cut across. And so look in that area of the step for other features like little, shadows on the DEM or something like that, where you may be able to find fault traces.
Great. Okay. And then the next one is the continuity of the fault traces. And this will mostly apply to the main primary trace that you guys draw. But if it's like the main primary trace, we think it's the largest fault in the area, the trace should be continuous throughout the entire landscape, because the assumption that when it's not continuous is that in a future rupture, you wouldn't think that the fault would rupture along this unconsolidated sediment or through water, through urbanization. And a map on the left might look like the case if you were just mapping actual surface rupture after earthquake, and those might be more scattered and discontinuous. We're trying to make a pre-rupture map of where the rupture may occur in the next earthquake. And so we do want to capture that in an earthquake, there is a chance that the earthquake would rupture the entire continuous strike of the fault trace that you guys place. And there might not be evidence, like clear evidence of that on the landscape or whatever imagery you're looking at. So that's why we like to use that kind of uncertain contact to connect any of like the lines that we're certain about with other GIR features. And this might not be the case for like smaller features, but if you see a bunch of traces that generally match up in strike, and you think they're part of the same fault, then you do want to connect them with the uncertain trace and make it a bit more continuous and have the right assumption that if it were to rupture, it would probably rupture right there, but there's just no clear evidence in the surface as of now to indicate a stronger fault confidence ranking for it. Okay. And then this next one, mapping at the full resolution of the data. And so this is going to apply to students who use more than one data set, maybe of one of poor quality, and then they get another set of imagery that's at better resolution. And so with the SRTM or other imagery that's of poor resolution, it's still a good tool to use to try and find the location of the fault and some GIR features. But oftentimes the fault trace or the shape of it won't be as accurate because the data doesn't fully encompass all of the nuances of the topography. So we want to make sure that when we have the better imagery, we use that in conjunction, and then we can kind of reformat the trace to better match where the topography is leading. And so like with this one, this was a 30-meter SRTM. And so the initial fault trace is quite linear because you can't really see the base of the range front here with much accuracy. But if we were to look at it then with the base imagery right here, you can kind of start to see where the trace could match up a little bit, maybe with some of the vegetation lineation. And if we even zoom in somewhere to like right here, you could see that the trace could be moved up and down a little bit. You could see a smaller sac pond right here. And you want to make sure that when you have the better imagery that you can kind of use the vector tool or redraw the trace to kind of make it just like that more accurate and cleaner. And so like, it's like kind of like a little rougher one, but then you like match it a little bit closer with the vegetation lineation, a little closer to the sag pond. So with the better imagery, you could just kind of suss it out a little bit more and make it a little bit cleaner. This might even be more with the case with like the range fronts too, matching up a little bit closer to the range front if it goes up or down instead of just a strict straight line through the topography.
Yeah. So the question in class is, should fault confidence be used all the way, the whole process of using fault, figuring out fault confidence with the different data sets? And I think the answer to that is yes. Like, you're going to refine it, but you still keep in mind your confidence calls, and your confidence may improve if you have some better data, that you can kind of suss out better confidence, and you can describe that in your write-up. Sometimes you get better data, you get a little more confident, you see a feature that's definitely a fault, that sort of thing. Okay. So it's an iterative process with the different data sets, and your confidence may evolve. Yeah.
And sometimes like if I don't want to do the fault confidence ranking right away because I know they may change depending on the data, I'll make a separate shape file that just might be like proposed fault, simple fault, and draw them out so I don't lose track of where I'd like to go back and look at them. And then once you get the better imagery and you start to work with the GIR a bit more, then you could start implementing the confidence ranking then for the fault traces that you've already created.
Just wanted to say, so the Alquist-Priola laws that we discussed earlier generally preclude building structures that humans will live in within 50 feet of the fault. So if you have data that support getting really that high accuracy, for example, meter scale LiDAR data, then you do need to really take advantage of that data, because how you read the landscape and move the fault can really be important on that 50 feet or so scale.
Yeah, and literally they'll take on a site investigation, they'll take a tape measure out, from where, and use the map. And so from where it's mapped, they'll measure 50 feet perpendicular to that fault. And they might put their structure right up to that 50-foot limit. So knowing exactly where it is a good thing.
Cool. Any other questions, comments? Sweet. And then Sven, Ramona and Rich already touched on briefly, but looking at the greater geologic context of the area. And so you guys, for the repeatability, are given the sense of slip or the general tectonic setting of the area to kind of keep in the back of your mind when you're looking for certain features to see if they make sense in that kind of tectonic setting, if the strike or the geometry of the faults would make sense in that kind of tectonic environment. And so with the fault trace placements, you want to make sure that they make sense for that. And traces that you draw shouldn't deviate too strongly from that main location or the main strike that you've already created. And so this is still in Parkfield, California. And so if I didn't look at this hillshade like from all the way back here, I wouldn't see all of these like general lineations in the hillshade. Maybe if I were to just kind of zoom in on this area and I didn't look at anything zoomed out beforehand, I might think that these linear valleys and these linear drainages might be fault traces if I didn't know. But since I know that this is a strike slip area on the San Andreas Fault, I do already know the general strike of the faulting, as opposed to like some of the other areas. I know that in some of them areas, you're not going to know the strike of the fault already, but you will know the sense of slip direction. And so it's important that you want to kind of zoom back out. And if I zoom back out and I already have the fault traces on here that I made, if I look back to where that was before, you would see that this wouldn't quite make sense in the greater geologic context. And if you zoom out even more, you would see that all the general strike and lineations and the topography don't quite match up with that. And then the same thing with Boar Peak too. You do want to kind of like zoom out past the extent of the mapping area to see, and you can kind of project your fault through the mapping polygon and see if it were to continue across that imagery, would you see some sort of evidence past that too that would make sense, or would it kind of stop abruptly and then it would cause you to take a second and then maybe reassess where you have the fault trace placed? That was it for the mapping ones, unless Rich and Ramon or Chelsea, you guys had any other notes about the mapping before we talk about the reports?
Looks
I
good.
guess,
Thanks for the review.
Let's see, I guess two things. Or one thing about the mapping is, you know, we want to use the geomorph to find faults, and we use the GIR to help kind of clue our eyes into that. But you want to be careful of just not connecting GIRs in lots of different orientations. So this just gets back to the point that Rachel was just talking about, the regional strike continuity of the traces. You know, just be careful not to put faults going all different directions, right? And especially some faults do curve a little bit, but you want to try to avoid really kind of circular lines where you're kind of outlining, say, a steep edge of a mountain or a steep edge of a hill or something like that. If it's curving way around in circular patterns, it's probably not a fault. So think about strike continuity. You know, your primary trace is going to generally follow a sort of consistent strike. Secondary traces can be off that strike a little bit. But yeah, just try not to kind of connect GIRs in all different directions. Think about the kind of the regional context first before you really start connecting those features. I guess that's the only comment on that. I had a comment on the report stuff too, so I'll state that.
Cool. And if you guys still have any questions too about what was mentioned with just now in the mapping discussion, or any comments too about the mapping for the return projects, let us know and we can like meet up separately or during office hours to talk about it. But for the report, it was just pretty much like two kind of small things. We want to make sure that in the report we have an introduction into the assignment instead of just like go off with the data sets and the figures. So they should include an introduction that just kind of outlines the project and then what you plan on discussing in the report, kind of like any other report generally. And then the figures, again, just include a north arrow, scale bar, legend, and for some of like the vignettes, I like to have like a little inset image that you could do on QGIS pretty easily, or Illustrator, that just shows where on the main mapping that you guys are zooming into, and it just makes it a bit more clear for the reader to see exactly where on the map you guys are directing them to, especially if it's like very zoomed in and it's in a larger area.
agree with the comment on the having a beginning short introduction to your report. The other thing is for each vignette, it's a good idea just to start to describe where you are. And that makes it much easier for the reader or grader to get the context of what you're talking about before you dive into the details.
Yeah, and we know that we specifically didn't really ask for an introduction, but it's just kind of something that we always do if you're writing something for anybody. It's just, even if it's just a short sentence or two, like just introducing what, you know, what the content is that's coming, right? So in the future, think about having some sort of introductory statement.
Cool. And then just the other point too, more so about the discussion of faulting. We want to make sure that we're including a little blurb, not just so about each of the rankings for the fault confidence and how the mapper decided to rank each segment according to like 1, 2, 3, because it would be like strong, it's a lot of high GR features, uncertain is little, which is true, but we do want to have a little bit more information about it because there is something that happened in the mapper's mind that made them pick distinct or weak. And so just write out the process in full, and it could be as simple as like, I determined it was strong because it had this many features, or distinct because of this, but we want you guys to explain each of them in the assignment and how you guys came to the conclusion for each of the fault confidence rankings. And it could be as simple as like, it was distinct because it was next to a strong, but it didn't necessarily have as many GIR features, or they might not have been as high of a ranking. And then we also want a little description too of the primary and secondary traces and how you distinguished between the two.
Yeah, so that just brings up the comment that I had is that, you know, it's good to have sort of a general discussion of sort of how you determine primary versus secondary, strong versus distinct versus weak, that sort of thing, just generally for your, you know, for your whole project sort of, and then provide details in the detailed discussion areas about those same items, confidence, primary and secondary. And you can, you know, pick a few examples or something out of that detailed area or something, but just so we can kind of see the connection between the general reasoning and then how it was sort of applied to the detailed area.
Yeah, because if you already did kind of like write in depth about it the first time around and you don't want to repeat the same exact information for the second report, you could do what Rich is talking about and maybe make it a bit more specific to the mapping area and include more site-specific details about your ranking system. And then rubric, yes, the same rubric. And I don't know if Ramon or Rich had a few comments about the rubric too either.
No, except that, yeah, we'll use the same rubric. So, you know, everybody should just be aware of that and make sure you're helping us find points for you on the rubric. So, you know, it's kind of meant to be a way to be thorough and consistent as the grading is done.
But a general other comment about the writing, which is that it seems that there was some amount of either complaining or just judging the data for being bad. So you really can't, it's not professional to say the low quality data made it hard for me to map. So that low quality really doesn't say anything. It's very judgmental, or it's just not, it's very subjective. And hard is irrelevant. It's your job in this class to figure out how to map, and we're giving you the best pre-earthquake data that we've been able to find. So what's more appropriate is to say like the 2-meter resolution and the presence of high vegetation made it challenging for me to separate, I don't know, say faulting from fluvial features. But this is then how I worked through that challenge to produce the map that I'm showing you here.
And that was this is the last slide too. So that was all I had, but I'll post the PowerPoint too online for everyone if they would like to look back at it later too after class.
Yeah, and for the writing, I'd also say just be sure you use headings, you know, for each section. It just makes it easier on the reader to know which section you're writing about, that sort of thing. Just standard professional writing, you know, and yeah, use headings. You don't need to include the questions from the assignment, you know, in the write-up, you know, just we know what those questions are. And I know that, you know, some of you put them in there to make sure you address everything, but when you're final, and when you final turn it in, you can take that part out, just have the heading, you know, just like a professional report.
One question that I have, or I guess like comment that I have about the report that was confusing is that like, I felt like there should be an intro, but there is no requirement for that. And just like, I don't know, it seemed like the expectations and like the formatting was a bit confusing. So having something like a discussion like this before a report is due would be nice in the future. Just like as a general.
Yeah, we didn't take any points off or no introductions or anything like that. It's just you know, moving forward.
Yeah, it just felt awkward to write something that might not be required, but then it felt like it was needed. And like, yeah, anyway, that was just like a thing that I noticed when I was making the report.
Yeah. Well, we wouldn't like write like make sure you have a conclusion or like make sure you have an introduction, because like generally in every report that you write, that would be expected up until this point, because you're all like graduate students at this point. So it would be expected that like if you wrote a report, generally introduction, conclusion, we didn't take off any points for it because what we cared more about was the actual mapping and the way you guys described it. But yeah, in the future now that you guys like do know, we hope that you guys all include it. And so then probably next time around, it'll probably just come off of like style and organization points too. And they don't make up a huge portion either of the grade. Either you'll see that the fall mapping is like at least a quarter of the whole assignment grade. So, but it's just kind of like small note too. We didn't take any points off of it this time around, but. That was all I had presentation wise too.
Thank you, Rachel. So just as a reminder, please be ready to discuss the Analecta reading on Thursday. We're not going to have any breakout rooms, although we'll give you updates for office hours on Thursday. I'll probably have them on Friday, but you can certainly get in touch with any of the instructors if you have comments or you'd like to meet us individually. Office hours have generally been pretty quiet, so if you come, which we appreciate, you probably will get an individual meeting. Ramon has a comment.
Yeah, I just I'm just was slightly confused. So you said there's no breakout rooms for map review, but Rachel said there would be breakout rooms for paper discussion.
Sorry, that is confusing. So yes, Thursday we're going to be discussing Analecta, the reading, and that discussion will be a combination of the big class discussion, but then we're also going to have a little bit of discussion in smaller groups for you to discuss, for example, what you think is the main take-home point from the reading. And then, so we'll discuss together, then we'll give a few questions to go discuss with smaller group in the breakout rooms, and then we'll come back and discuss those questions as a class. The idea of using the breakout rooms is that we then hope that it's a little bit less intimidating than speaking on the Zoom to 20 or so people. and it's easier to engage in discussion with, say, 5 or so people.
Yeah, so I think the main take home point of the paper, and then anything that was interesting, you guys will have a chance to talk about that in a smaller group, you know, and come up with some kind of consensus of what the most interesting parts were, and then maybe relate that when we come back together.
Yeah, and I'll just give the advertisement. It's a really kind of really clever and original paper that is somewhat influential, although not well known in some ways. It kind of like it's sort of underneath a lot of subsequent thinking about surface ruptures and the kind of mechanics of the deformation, but also the style of deformation, you know, these sort of belts of shear, and also comes from a group that's kind of well known for really deep thinking about the sort of straining of these zones. So just take the time. You know, you can even tell, like, analecta, it's kind of interesting word, you know, it means sort of a collection of short extracts, and it's you know, their effort to sort of pull together some observations that they had made and synthesize them. So, you know, try to motivate to read it. I think it's worthwhile, and then it helps you build intuition that will feed into the sort of, you know, second mapping project and thinking about how surface ruptures might look.
And then side note, I won't be actually having office hours on Friday because a few of us are going into the field, but I can have them either tomorrow or Thursday or before class on Monday too, or on Monday before class Tuesday, whatever works. But I can also, if you email and want to meet, I can suss out a different time.
So
They just won't be.
I'll have them, Rachel, at the time that you would on Friday. But if there is anyone who would like office hours tomorrow or Thursday, then please get in touch with us and we'd be happy to set that up. So I'd be happy to finish class early, or if you guys have any questions, talk either individually or in the group. We're half an hour early, so that's half an hour more of mapping if you guys would like. Oba.
It's just a tiny question, but you've discussed about resolution last class. I was wondering, so if it's written in the metadata that it's 6 by 6, then it means 6 pixels per 6 meter per pixel, right?
Yes, well, generally you do want to find the unit to make sure that it is meters, but it's 6 something by 6 something. And
Sure.
Just as a caution, a lot of American data sets are in feet, so it's important. Even they can be a combination of feet and meters, so just generally check.
Yeah, I've double checked. It's meters, so it's 6 meters per pixel. That's it.
Correct.
Okay, thanks.
I'll just add that anybody from UNR who has any questions about grading and stuff, just come talk to me individually. Happy to discuss any of the comments you made. there was no other questions from the classroom here.